Linear inequalities. Inequalities. We could talk about greater than, less than, equal to, not equal to. So when we talk about the linear inequalities, we're talking about a variable term being involved in a straight line. So we have a set which will be written in parentheses, and these three here are all sets. And then we have a set builder notation, which this is the set builder notation right here. This is the set builder notation. I'll get to that here in a minute. So on the first set, I have A is equal to these set of numbers. It's finite because those set of numbers are literally within those set, and that's it. These are the sets that we're using, and that's it. Where W says 0, 1, 2, 3, dot, 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 meaning going off to infinity, right? We have a set that's 0 to infinity. I use parentheses on this because, one, we cannot stop infinity, so we always use a parenthesis on it. I use a parenthesis on 0 because it's not determined here if it's opened or closed, but this is a notation. This set of Z, though, says dot, 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 all the negative values all the way through 0. And then it also has 0 and then through all the positive values. And then it says dot, dot, dot. So this is the infinite set, right? Because it's going off to negative infinity and positive infinity. It's including all numbers on the number line. So if the set is empty, this is the notation that you will see. It's called an empty set. This here is my set builder notation. It just means that the set builds on X. This is a straight line. This X is the set that it's going to be built on. And right here it explains how it is. And here's the wording. The set of all X such that what? Well, it's empty right here because I haven't filled nothing in. But below it, I use this as an example. And I said that this set builds on X where A is less than X less than B. So when I was to read this as the set and builder notation, I'd say this set of all X such that X falls between A and B. So if I was to graph this on the number line, I would say A is here, B is here, and X falls all between here. And since this inequality sign doesn't have an equal sign on it, then it's open. And it's going to be a parentheses. And since this equal sign don't have a bar on it, meaning that it's equal to, then it's open too as well, and it has a parentheses. So if I write it in interval notation, I would say this. I would say that everything between A and B, and it's open on A and B. So the interval notation, that's what this is. This is the set builder notation. Interval notation, if there's parentheses on both sides, then it's an open interval. If there's brackets on both sides, it's a closed interval. This means that we have something like this, right? That means it's closed. If it's half open interval, then that means, let's write an example. A is less than X, where X is less than or equal to B. It's a half opened. It's opened at A, but closed at B. This one here is another half open, so let's use A is less than or equal to X, where X is less than B, then it's closed at A and open at B. So it's important that you understand how to do the interval notations. So there's one rule that always applies, guys, and that is infinities, I apologize. Negative infinity and positive infinity. You can't stop either one of these. This means that it goes on and on and on, right? So we're going to have an open interval on both of those. So that's where we use parentheses. So anytime you have a negative infinity or a positive infinity, you always have parentheses. Let's do this example 1. Example 1 says graph 3, infinity. And you notice they both have parentheses, which again, infinity always has a parentheses. So let's graph it. I'm going to put 0 right here. 3 should be about right there because it's a positive 3, right? Everything on this other side of the 0 is going to be negative values. And it's opened at 3, so it'll be an open circle. And I'm going to shade off to positive infinity, right? It's going to have a parentheses on 3 because it's open. So my interval notation is this. This is graphing it. So on example 2, let's graph it. We're going to draw a number line. On this number line, I'm going to plot my 0. That's a positive 4, so it goes down here. And it says that x falls between 0 and 4. It says that it's open at 0, so it gets a parentheses. It says it's closed at 4 because of the equal sign on it, so it's closed. It gets a bracket. So my interval notation will look like this. And that's what my graph looks like. Let's do this example here at the top, and I apologize, there it goes. At the top we have a set builder of x where x is less than or equal to 2 and x is greater than or equal to 0. So what I'm going to do is I'm going to draw 2 number lines. My first number line is going to be the x is less than or equal to 2, so I'm going to plot 2 here. It's positive. If you want to put a 0 on there so you know that you put it on the right side, then I would. If it's less than 2, then that means we're going off to this negative infinity, right? And it has the equal to sign on it, so I know I'm going to put a bracket, right? So underneath it, let's plot x is greater than or equal to 0. I'm going to line it up with that 0. I'm going to make sure that my graphs actually line up together. And it said that it includes, right? It's equal to, so it includes. We have a closed 0 or closed circle on where it includes. We have a bracket. And it says x is greater than 0, so it goes off to this infinity, right? Now, when we're comparing these two, because we're determining what is the actual set, if we was to really look at it, these two are in common at 0, 2, and since we both have an equal sign, we have to do this. Now, if one of these didn't have the equal sign, then they would get one of them would get a parentheses. So make sure you read to see if it has the equal sign on it or not. So my interval notation says that this graph set has an interval of 0 to 2 that's in common. If for some reason, for example, it did not, so say that it went the opposite direction, say it was negative 2 in this direction and 0 in this direction, then when we would have graphed it, this is where we would have got the empty set because it wouldn't have had anything in common. So just be sure and read and look to make sure if it has equal to on it or not. That will determine the parentheses versus bracket. Also, if it's a positive value versus negative value. Here's some information. If you got time, you can read over it. Let's do example 7. I'm going to scoot it up where you can see it. We're going to solve this linear equation, and then we're going to graph the set, and let's write it in interval notation. So I have 6x plus 5 is less than or equal to negative 1. Well, in order to solve this, we make sure it's cleaned up on both sides, and it is. And then next, we're going to say, okay, let's isolate the variable term. So I have 6x plus 5 is less than or equal to negative 1. And I want to get this 5 on this other side, and since it's positive, we're going to subtract it. We're going to treat this like it's an equal sign. Positive 5 plus negative 5 is 0. So it leaves me with 6x is less than or equal to. Negative 1 minus 5 is negative 6. Now, we need a coefficient of positive 1 on x, and we have a 6 on it. So what I'm going to do is I'm going to divide both sides by 6. Guys, here's a little note. If I divided by a negative value here to get x to have a positive 1 coefficient, then the inequality sign flips. Okay, so note that. If, though, we're just dividing by positive, then the inequality sign stays the same. Okay? And in this case, we're not going to change it because we're dividing by a positive. 6 goes into 6 one time, leave me with x. Positive 6 goes into negative 6 and gives me a x is less than or equal to negative 1. So let's graph it. We have 0 here, negative 1's on this side, and it says it's less than, so it's going off to negative infinity. it's got an equal to sign, so it gets a bracket. So when I write this in interval notation, there's my interval notation. I'd like to do example 12 to give you something a little bit different than what we've been doing. What I notice here is I have a little bit going on. We had it just where it was one-sided, where x is equal to or less than. In this case here now, we're saying x falls between. Okay, so here we go. We have 5 is less than or equal to negative 3, which minus 2x is less than or equal to 13. So my x is falling between 2 points, and these equal to sign here is telling me it's closed here, and this one has an equal to sign, so it's closed there. So I know I'm going to be using brackets. So let's solve for it. Well, in order to solve for it, I have to clean up the middle, because I notice there's a lot going on there. So I'm cleaning it up. The x needs to stay here. The rest needs to move around. So I'm going to make this negative 3 go to 0. In order to make it go to 0, I need to add it. And I apologize. So I'm going to add 3 to both sides. Right? Because what you do to one side, you have to do to the other side. And since there's 2 sets of sides, we have to do it to the ends as well as the middle. So now I have 5 plus 3 is 8. 3 minus 3 is 0. Bring down the negative 2. 13 plus 3 is 16. So next we're going to solve for the x value. We're going to, by getting a positive 1 coefficient on x. And in order to get a positive 1 coefficient on x, so that means we need to undo the multiplication by dividing. But since we're dividing by a negative 2, a negative value, to get a positive 1 coefficient on x, that means we have to flip the inequality signs. So now I have negative 2 goes into positive 8, negative 4 times. I have negative 2 goes into positive 16, negative 8 times. You agree that if we was to draw this on the number line, the negative 8 is smaller than the negative 4 because it's getting closer to negative infinity than what negative 4 is. Another way of saying it is that this negative 4 is closer to 0 than that negative 8 is. So I can rewrite this where the negative 8 goes first. Make sure you rewrite these inequality signs correctly. Be careful with that. So I rewrote it, and I made sure my point sign arrows. So now when I draw it on my number line, I got negative 4 here and negative 8, because negative 8 gets closer to that negative infinity. So when I draw this out, it says x falls between these two. And I look, and they both have an equal to sign, so they get a closed circle and they get a bracket. So when I write this on interval notation, I get bracket negative 8, comma, to negative 4 bracket, because it's closed on both of those points. And that is solving for x in interval. So on this next interval inequality, the linear inequality that we're solving, we see that we have a fraction going on, and we see that x is falling between 2 points again. I also see that that where it falls, they're open at, so I don't have an equal to sign, so I know I'm using parentheses. That's a good note. If one of them had an equal sign, I would make a little note saying which one did and make sure that it got the bracket. But I also see that I have a fraction going on. So before I can do anything, I need to clean it up, right? So what can I do? I can take this and multiply by the denominator. And what I do to one part, of course, we do to all. And then we have 4 times 0 is 0. We know that 4 goes into 4 one time, so we undid the fraction, and now we got 3x minus 5. 3 times 4 is 12. So far, so good. Now we need to clean up where the variable term is, so we can start working on isolating it. So I have this negative 5, so I'm going to make it go to 0. I have to add it. And we're going to add to one part, add to all parts. 0 plus 5 is 5. It's less than 3x. Negative 5 plus 5 isn't 0. 12 plus 5 is 17. So far, so good. Now, I need a positive 1 on my x as a coefficient, and I see that I have a 3 on it. It's not a positive 1 coefficient, so that means I'm going to have to divide to undo the multiplication. This one here didn't turn out as pretty, guys. This came out as a fraction. 5/3 is less than x, less than 17/3. So when we draw this out on the number line, it's not going to be as pretty. We're going to have to know where 5/3 fall and 17/3 fall. So if you wanted to, you can use long division to get the decimal place, which is approximately 1.67 or 1.6 remaining, or 6 repeating. So it's going to be right past 1.5. It's going to be right in here for the 5/3. And then the 17/3, you can use long division again to come out with the decimal. It's going to be 5.6 repeating. So I'm going to say about 5.5. It's going to fall. I should have gave myself more room on this paper. Let's put 6 right here. It's going to fall about right there, 17/3. And it's open parentheses because there is no equal sign. It's opened. So my interval notation would look like this. Example 14. Example 14 is talking about a math student who has grades of 85, 98, 93, 90. And on 4 examinations. If he must arrive at a 90 or better to receive an A for the course, what scores can he receive on his final exam to earn an A? So we got we have 4 exams listed, and we're trying to determine what he has to make on the 5th exam in order to receive an A in the course. So I know that that's going to be 85 plus 98 plus 93 plus 90 plus x, and since there's 5 of them, we're going to divide by 5. And we know this grade must be larger than or equal to 90 because he wants an A in the course. It says he has to make a 90 or better. So this is how we would set it up. So what you'll do is you'll add up 85 plus 98 plus 93 plus 90, and you would get 366 plus x over 5. So in order to solve for this, we must undo the fraction. So I'm going to multiply everything by the denominator, which is 5. So now 5 goes into 5 one time, leaves me with the 366 plus x is greater than or equal to 450. And let's come up here to the top and finish this one out. Let me scoot it over, make sure you can see it. So now I have 366 plus x is greater than or equal to 90. And in order to solve for x, we need to get x isolated by itself. So I'm going to subtract the 366 from both sides. Oh, guys, that was a typo. It's 450 here instead of 90. So now I have x is greater than or equal to 450 minus 366 gives me 84. And the coefficient on x is 1, so we have it the way we want it. This is the correct answer. So this statement would be that if the student scores an 84 on the 5th exam, they will have at least a 90 or higher in the course, which will result in an A. That's exactly what the last one. I know this was a long video, but I'm hoping this will help y'all throughout this section. So on example 15, it said Ellen is going to buy 30 stamps, some 28 cents and some 44 cents. If she has $9.68, what is the maximum number of 44 stamps she can buy? So what we're going to do is we're going to label. Let's let X be our unknown number. of 44-cent stamps. I'm going to use some little notation. And thank y'all for bearing with me on this fuzziness. I'm not. Come on, Lord. I can't do this.